Hello, beautiful people, and welcome back to Unit 1 of Regents Chemistry, which is Math of Chemistry. Today, we'll be talking about the scientific method, which you guys might have heard of before. So, scientists do research like all the time, whether that is to come up with some treatment plans or just to fix something in the environment or in this world, or do anything like that. And whenever they are doing those types of researches, there is a step-by-step process that they follow. So let's look at what are some of the steps that they follow. So the first thing that they have to do is make an observation. Like they have to see or observe that there is a problem going on in the world. And they do that using the five senses, which are sight, hearing, smell, taste, touch. So for example, let's say I am making an observation that sugar dissolves faster in warm water. So that's my observation. Now, the next thing that I would want to do is ask a question about that. So my question would be, well, why is the sugar dissolving faster in warm water? Why is that happening? And then I will go ahead. So just ask yourself, what's the first thing that you guys do when you have a question that you don't know the answer of? Well, you're living in the digital world. The first thing that we do is Google it, right? So that's what scientists do as well. But their version is a bit fancier, a bit more professional. So they just do some research and look up if there are other people out there that have already figured out an answer for this problem. So, for example, when I am asking the question that why is sugar dissolving faster in warm water, I'll go ahead and do some research about that and collect some background knowledge. Now, for us in everyday life, for the most part, when we ask a question and we Google it, we do get our answers and we are very happy with that. But that is not the case with scientists because, for the most part, they pick up a problem or they observe a problem that not a lot of people out there have already worked on or they have not done any research on it. Or maybe there are some people out there that are doing a research on it, but they still don't have a conclusion. So they don't get their answers that often. So what they do in that case is that they devise a hypothesis, which is basically just a proposed explanation of their observation, which means they just make like a statement or an educated guess that why is this thing happening. So it's just what they come up with. Now, the important thing to remember here is that hypothesis is just a guess. It's a proposed explanation. So this is something that can be falsified. It can be proved wrong, which is very common. People always come up with ideas, but those ideas can be wrong. So in my case, I will say that my hypothesis would be that sugar dissolves faster in warm water because when we increase the temperature, the particles in our solution or mixture start moving faster. That is going to be my hypothesis. Now, once we have the hypothesis, the next thing we want to do is check it that how correct we are. So we want to do our experiment. Now, for the experiment, we set up some variables. So our first variable is the independent variable, which is something that we change. So for example, in my case, when I am testing uh, my hypothesis that sugar is dissolving faster in warm water, I have to compare that to the cold water. So I will be changing the temperature of the water, of about like how warm is it or how cold is it, stuff like that. And then there's another variable which is dependent on that independent variable. So, for example, and that's something that we observe. So, in our case, or in my example, that would be how long does it take for the sugar to dissolve? So, depending on what is the temperature of the water that I'm taking, how long does it take for the sugar to dissolve? And then we also have in some case, most of the cases, we also have a controlled variable, which is something that we are keeping the same because we want to make sure that that thing is not indirectly affecting our results. So in this case, one thing that I would want to control is the amount of sugar that I'm taking. Like I don't want to put more sugar in the first experiment when I'm using cold water and then put less sugar when I'm using warm water just so I can get the type of result that I want to get. So I will control the amount of sugar that I am using. Now, once we do our experiment, the next thing that we do is we gather our results or collect data. and then we have to organize that data in like graphs, tables, stuff like that. Okay, which you guys will also be doing ideally whenever we get to the labs. And then once we have those results, we analyze them. What does that mean? So analyzing the results means we compare our results with the hypothesis, and we see there are two things that can happen. First thing, our hypothesis can be correct, like proved true. So we'll be like, yay, we were right. And then the second thing that can happen is that our hypothesis was wrong. So either way, um, that's not the end of the world, because even if, let's say, your hypothesis was proved false or not correct, you can go ahead and come up with another hypothesis and then test that again. That's how this process continues in science. And then let's say that your hypothesis was correct. You did your research, you keep doing your research over and over and over again. You check it multiple times, and every time it prove you kind of got the same results. That's when it is time for you to present your research. Now for you guys, we just write the lab reports. Whenever like we are done with the lab, we do 2 or 3 different trials of that thing, and then we just present our result. For scientists, though, they write like the actual research papers that look something like this, and then those research papers are published in the journals, and that's when it becomes public. So then it's on Google, it's everywhere out there, so that when other people out there they kind of research this, they know that someone else has been working on the same thing, and these are the results that they got. So they either take their results, they agree with them, or they just challenge them. They're like, you know what, I'm gonna prove you wrong. So stuff like that happens in science. Okay, now let's say the research is presented and multiple people around the world have tested that, and everyone has pretty much got the same results that you did. So in that case, that hypothesis can become a theory. But the thing to remember here is that your theory can still be challenged, it can be denied, and it can also be changed. So your theory still does not mean that you have discovered something. Yes, you did come up with something which is great, and so far it is proving to be correct, but it can always be challenged, and theories are constantly challenged out there. But let's say there is a theory which is constantly being proved correct, and no one has ever challenged that, or even if people have challenged it, they did not come up with like enough evidence to just deny it. So in that case, that theory can then become a scientific law. And once a theory becomes a scientific law, it can never, ever be challenged or denied or changed. Okay? For example, Isaac Newton said that we can stand on the surface of Earth because of the force of gravity. And we still believe in that. And no one out there can ever challenge that because it's a law. Alrighty? So, all of these steps together make up the scientific method. And if you have to define it, we'll just say it's basically like a very logical, a systemic, very organized approach to coming up with the solution of a scientific problem, or to, let's just say, discover something new. Okay, so to summarize, the steps that we discussed were, first of all, we have to make an observation. Once we have an observation, we ask a question about that. And then we do some research to collect some background information. Maybe we'll get our answers right then and there. But just in case we don't, we go ahead and make a hypothesis about that, which will be an educated guess. Then we do an experiment to test our hypothesis. And after the experiment, we collect our data or results, we analyze them, means compare them with the hypothesis to see how correct we are, and then we present our results. If we have done the experiment a lot of times and every time we got the same result, we can be confident to present them in lab reports, or in case of scientists, in the research papers. And then if a lot of people out there in the world have tested that same thing and they came up with the same results, then that hypothesis can become a theory, which can still be challenged, it can be denied. But once the theory has been tested multiple times and it was not challenged enough, or it is still holding true, that's when it can become a scientific law, which can never ever be challenged or denied. Okay, so that was it for scientific method. Happy learning, and I will see you guys in the next part of this chapter.